Talk Chemistry with Pastor Dan. We're looking at, if you look on top here, you see we're looking at, it's called Ox Redox Reactions. Now, this is an example of an Ox Redox reaction. You're going to go, wait a minute, Pastor Dan. That's a single replacement reaction. A single replacement reaction is an oxidation reduction reaction. Let's do it here. I've got an element of compound, so my element is going to replace the metal, the cation. So we're going to put AlCl, remember oxidation numbers. Aluminum is +3, oxygen is -2. So we get AlCl3. Copper is the odd man out, balancing it up. 2 and 3, balance my chlorines, then balance my aluminums and my coppers. We're good to go. All right, now, this is also an oxidation reduction reaction. Now, you could try to do what we just did there, metal, non-metal, hydrogen, oxygen, but it's going to be a lot more difficult and there's going to cause a lot of frustration. So there is a different way of doing it, and that's called a process called oxidation reduction reaction. Definition of an oxidation reduction reaction is a type of reaction where balancing is done based on the number of electrons lost or gained. Now, the first thing we have is an oxidation. That's elements that lose electrons. Now, when we lose electrons, my oxidation number is going to be going up. It's becoming more positive. You got to think about it. Electrons are charged negative. If I lose negative, I become positive. Think of it like a debt. You owe $65,000. The next day, you only owe $10,000. You lost $55,000. You lost something, but you're much more positive because you lost a negative. All right, so if oxidation is losing, then reduction, whoa, not clone, let's get rid of that. Reduction is elements that gain electrons. Now we have two other terms here we also have. We have what's called an oxidizing agent. It's an element that causes oxidation by being reduced. The one that reduced is the one that causes oxidation. So we call that the oxidizing agent. And transversely then, the reducing agent is the element that causes reduction by being oxidized. Now we have a way of trying to remember this. Think oil rig. Oil rig, yes. Oxidation is losing oil. Reduction is gaining rig. So oil rig. Oxidation is losing. Reduction is gaining. All right, so the steps in it. We're going to go through this quickly. First, we're going to identify the oxidation numbers and elements that are going to change. There's always going to be two. One's going to be oxidized. The other one's going to be reduced. They're going to be one of three separate elements. First of all, let's find an element by itself. Why? An element by itself has an oxidation number 0. It has no charge when it's by itself. When it's a compound, it's going to be having a charge, so therefore that's a change. If it's not that, we're going to look at the metals we don't know. In other words, not an alkali, which are +1, not that one. Not an alkaline, that's +2. Not silver, zinc, aluminum, +1, +2, 3. Any other metal that's not one of those, we're going to go to that. The third one is the center of a polyatomic ion. We'll look at that center atom polyatomic ion in that way. Then we determine the number that are lost and gained, so we identify, and then check to see if one element on each side, if not multiply. Now that's a hard step. We're going to show you a couple times that process to get that third step understood. And they get the number of electrons lost equal number gained, balanced by inspection. Of course, that is metal, non-metal, hydrogen, oxygen. So write down those steps. Those are the steps for oxidation reduction. So let's go back to the one that I showed you. Okay, so do we have an element by itself? Yes, we have iodine. Iodine here, oxidation number 0, element by itself. In HI, iodide is -1, so that's a change. From -1 to 0, that's a change. Now, do we have any other elements by themselves? No. Any metals we don't know oxidations? No. So now we're going to go to the center of the polyatomic. Now, this is the only time we go into the center of the polyatomic. I'm going to break all the elements apart. So let's go to the product side. Oxygen is -2. And I know you know, wait a minute, nitrogen is -3. We're going to forget what we knew before. We're going to assume everything's ionic, even though that's not necessarily right, in order to do this process. So oxygen is -2, that would mean nitrogen is +2. Now we go to the center. We're going to go to the center here. We're going to do oxygen and hydrogen first. Oxygen's oxidation state is -2 times 3 is -6. Hydrogen, plus 1 times 1 is plus 1. So what number would nitrogen have to be to equal 0? Well, it would have to be plus 5, so nitrogen's plus 5. So plus 5 to plus 2, that's a change. All right, if I go from -1 to 0, I'm going up, becoming more positive. That means I'm losing 1 electron. But when we check our second step, I'm going from 5 to 2, I'm gaining 3. Now the third step, I'm going from 1 iodine to 2 iodines. So we're going to put a 2 in front of the iodine, and we're going to multiply by the multiple. And that's why I use the little time sign. So I'm losing 2, I'm gaining 3. The least common multiple of 2 and 3 is 6. So I'm going to multiply the bottom one by 2, and the top one by 3. So I'm going to put, where it touches, I'm going to put 2s. So I'm going to put a 2 there, and a 2 there. Where it touches on the iodines, I'm going to put 3. So put a 3 and a 6. Now I balance by inspection. There are no metals. Non-metals, I have 2 and 2. Hydrogens, iodines, I have 6 and 6. Hydrogens, I have 8. So put a 4 over there to balance that up. And oxygens, I have 6. I have 2, 4, that's 6. That's balanced. Now, let's do this oxidation, reduction, oxidizing agent, reducing agent. Which one's losing? Iodine's losing. Which one's gaining? Nitrogen's gaining. Oxidizing agent, which one caused oxidation by being reduced? Nitrogen's reduced, so that would be nitrogen. And which one caused reduction by being oxidized? Iodine's oxidized. So there we go. Let's try a couple more. Let's do this one up here. Start with sulfur. Again, element by itself, 0. Hydrogen sulfide, -2. That's a change. Now we're going to do any metals, no. Any metals, any elements by themselves. So we're going to go to polyatomics. Again, that's nitrate. That's exactly the same. So we're going to do -2, +2. And HNO3 is exactly like we did before, so it's still +5. So we're going to connect those two. If I go from -2 to 0, I'm going up. I'm losing 2 electrons. Going +5 to +2, I'm going down. I'm gaining 3 electrons. Now check my third step. Do I have 1N? 1N, yes I do. 1S, 1S, so there's no multiples. I can skip on to the fourth step. 2 and 3 leads come multiple. 6, it's going to multiply the first one by 3, second one by 2. Put 2's in where they're attached. Put 3's in where they're attached. Now my balancing, I got 2 nitrogens, 3 sulfurs, 3 sulfurs. I have 6, 7, 8. So I got to put, there we go. Sulfur's losing, nitrogen's gaining, oxidizing agent nitrogen, reducing agent sulfur. Let's try this one. Again, we have an element by itself, that copper over here, element by itself is 0. Now, we don't need to bust NO3 apart because I'm not going after the center. So I'm going to keep NO3 together, nitrate. Its oxidation state is -1. If nitrate is -1, times 2 would be -2, so copper would have to be +2. That's a change. All right, NO3, that's the same again, so we can save ourselves some time. +5, oxygen's -2, +2, so that's a change. All right, going from 0 to +2, going up, I'm losing 2. 5 to 2, I'm going down, I'm gaining 3. And again, 1 copper, 1 nitrogen, 1 nitrogen. We're good balanced. Common multiple 2 and 3 is 6, so multiply by 3, multiply by 2, put 3 and 3, put 2 and 2, now balanced by inspection. Coppers are good. Nitrogens, I now have 6, 7, 8. So I can go up. So that becomes 8 there. Now I have 8 hydrogens. I have 2 hydrogens. So put a 4 there. Oxygens lastly, 8 times 3 is 24. I have 18, 19, 21, 2, 23, 24. That's all balanced. Do our oxidation reduction. Which one's losing? Copper's losing. Which one's gaining? Nitrogen's gaining. Oxidizing agent nitrogen, reducing agent copper. All right, 2 more here, and the last one. I really like these. I know they may be a little strange to you, but I think of these like Sudokus. They're a challenge problem. So let's do the first one. Okay, sulfur, 0, element by itself. We're going to go to the opposite side. Oxygen, -2, times 3 would be -6, so sulfur has to be +6, 0 to +6. There we go. Now, we're at the center of a polyatomic ion, so this time we are going to break it all apart. -2 times 7 is -14. Potassium's +1 times 2 +2. So what number would have to be? That'd have to be 12, but there are 2 of them. So what number times 2 is 12? That would be 6. So +6 go to this side. Oxygen is -2 times 3 is -6. Chromium would have to be +6, but there's 2. So that's +3. That's a change. I'm going from 0 to +6, going up, losing 6, going 6 to 3, going down, I'm gaining 3 electrons. Now, third step, my sulfurs are good. My chromiums, even though they're already balanced, it's still a multiple on both sides. So we're going to multiply by the multiple, multiply by 2, I have 6. We're now balanced. Nothing to worry about, just balanced by inspection. Potassiums are good, chromiums are good, sulfurs are good. Check our hydrogens. I've got 2 and 2. I've got 8 and 8. That's balanced. So oxidation, which one's losing? Sulfur, reduction, gaining, reducing agent, and sulfur. All right, now, that last one. This one is an incredibly fun one. I know, I'm a little sick and weird sometimes. But let's do this one. Let's do this one here. All right, do we have any elements by themselves? Not here. Any metals? We don't know the oxidation number. This time we do. Okay, we have iron. We don't know iron. So if we look at iron on the reactant side, it's -2. I'm not breaking SO4 apart, keeping that together. So sulfate's -2. That means iron has to be +2. Go on the other side. Sulfate is still -2. I don't care about sulfur. Times 3 is -6. +6, so that means a change, 2 to 3. All right, now, do we have any other metals? We don't know. Nope. So now we're going to polyatomic. MnO4 is permanganate. That's a polyatomic. We're going to break it all apart. Let's go to the product side because it's easier. So sulfate is negative. Whoa, I started the wrong thing. Let's go. Sulfate, -2. So manganese is +2. -2 times 4 is -8. +1 times 1 is +1. +1 minus 8, -7. So +7. So +7 to +2. That's a change. All right. Now, are my manganese 1 and 1? Yes. Are my irons 1 and 1? No, they're not even balanced. So let's get them balanced first. Put a 2 right there. Okay? So now we're going to multiply by 2 because that's a multiple on both sides. 5 and 2 least come multiples. 10. Multiply that one by 5. Put a 5 there, and we're going to multiply up. That's going to become 10. All right, multiply this one by 2. 2 and 2, good to go. Potassiums are good. Irons, good. Sulfurs, oh boy, this one's tough. I've got 2, I got 15, so that's 17, 18. Now I don't want to touch this one. So 10 from 18, that's 8. So I'm going to put an 8 right here to balance those out. I now have 16 hydrogens. I have 2 hydrogens. So I'm going to put a 2 there. Let's check our oxygens now. I have 8 times 4, which is 40. I have 2 times 4, that's 8. I have 8 times 4, that's 32. Altogether, I have 80 oxygens. Whoa, 80 oxygens. All right, on the product side, I have 2 times 4, that's 8 oxygens. I have 4 times 3, which is 12, times 5, that's 60 oxygens. I have 4 in KSO4, K2SO4, and then 8 times 1, I have 8. Add those up, we also have 80 oxygens. Which one am I losing? I'm losing iron. I'm gaining manganese, oxidizing agent manganese, reducing agent iron. All right, there we go. Hopefully that wasn't too bad. We will practice for 4 days before the test. Any questions, let me know. Take care. God bless.